At dawn, zebras drink at a waterhole. Antelope wait at the edge. Then a lion roars nearby. Heads lift, bodies lock. The herd bunches together. They stare into the brush and test the air. But most do not explode into a full run. A moment later, a hidden speaker plays a calm human sentence. No shouting, just the kind of voice you might hear from hikers, campers, or tourists near a road. Now the waterhole empties. Hooves hammer the dirt. Animals scatter. They leave the water behind, as if drinking has suddenly become dangerous. So, why would a normal human voice make animals bolt harder than a lion's roar? Here is the careful answer. Not all animals everywhere. In some experiments, many reacted more strongly to humans than lions. Researchers test this with field playback experiments. Hidden speakers play sounds. Camera traps record whether animals flee, abandon water, stay away longer, or scan instead of feeding. In some ecosystems, especially where people pressure wildlife, human voices become high-risk sounds. A lion is deadly, but it is a familiar danger. It hunts in certain ways. A human can mean roads, dogs, traps, guns, groups, tracking, noise, and return visits. That is the reversal. The calm voice is not powerful because it is loud. It is powerful because, in some places, it points to a broader and less predictable danger. This is why trail talk, campsite chatter, and tourist noise can matter. Human sound can change when animals drink, where they feed, and how long they stay in the open. So if lions can kill, why is their sound sometimes easier to handle than ours? What do animals understand about lions that they cannot predict about humans? Sometimes the scariest predator is the one you can't read. A zebra lifts its head above the grass. Its ears point forward. It sees lionesses low in the cover. It does not run yet. It watches. The lionesses are deadly, but they are also familiar. They move in a pattern the zebra can test. Are they crouching? Are they close enough to rush? Is there enough grass for a hidden stalk? This is the first key idea. Fear is not only about danger. Fear also depends on whether the animal can predict what comes next. Lions often hunt in repeatable ways. They use certain places, certain times, and certain attack distances. Prey learn these patterns, and evolution shapes instincts around them. The rule is not that a lion is safe. The rule is that a lion can often be read. That zebra is running a simple lion algorithm: distance, posture, speed, cover. If the lion is far away, standing tall, and not stalking, watching may be better than wasting energy in panic. Now put a person on the same trail. The animal cannot read one clear script. Will the human pass by, approach, chase, hide, return later, or attack from far away? When the pattern breaks, caution wins. Distance becomes the safest answer. So, if predictability is the key, what exactly makes humans so hard to model? What predator rules did we break? A deer steps out to feed, and the first warning isn't teeth or a roar. It's footsteps on dry leaves, then silence. The deer freezes, scans, and sees nothing. Only a thin human scent line sliding on the wind. That's the problem. With humans, the danger doesn't have to be standing right there. What makes humans such an extreme risk signal compared to a single predator like a lion? It's that a person is rarely just one hunter. A human can be the front edge of a whole toolkit. Minutes later, a hard crack rolls across the valley. Somewhere far away, something was struck from a distance. Then a dog barks, and the bark keeps coming. Then headlights sweep along the road. Then the deer runs and hits a fence that wasn't there in its grandparents' time. To wildlife, human can mean weapons that reach farther than any leap. Partners who spread out and push. Traps that wait while nobody is present. Vehicles that close gaps fast. And people who come back later with memory and a plan. Ecologists sometimes describe us as super predators because we can kill efficiently across many kinds of animals, and not just the weak. Even when nobody gets hurt, studies show simple cues like voices, footsteps, or scent can change feeding and movement. So a quiet hiker can still read as the start of a chain: pursuit, long-range harm, and being cornered by infrastructure. But how did ancient humans become this tool-using, cooperative predator in the first place? Weren't we once the ones being hunted? Dry grass scratches bare ankles as a small band of ancient humans pulls closer to a low fire. Faces glow, then fade back into dark. Outside the light, eyes flash and disappear. Early humans were not born as rulers of the landscape. For much of prehistory, they likely lived with real predator pressure. So how did human evolution turn ancient humans into a predator animals could not easily predict? It happened slowly, not with bigger claws, with small advantages that built on each other. People learned to read tracks. They watched wind, dust, broken grass, and tired movement. They shared signals. They moved with shared intent. One person could follow, another could wait. A group could keep pressure on an animal until heat, thirst, or panic made a mistake. Fire later changed the night. It made a resting group harder to approach. It marked human space. It let people gather, plan, and stay awake together. Stone tools changed the hunt. A sharp edge could cut hide. A later shaped point could carry danger forward. Over time, hunting became less about one sudden charge and more about memory, timing, and a plan. That is the twist. Humans became frightening because they broke the usual rules. We were small beside many predators, but we could return, coordinate, and use tools. Modern wildlife fear can still echo that long history. If ancient humans were already getting better at hunting, what changed when we teamed up with another predator? Wolves that became dogs. We didn't just invent tools, we recruited another predator. At an ancient camp, a gray wolf waits near the edge. It can flee, but it can still smell scraps. It watches people and learns their routines. Generations later, camp followers become early dogs. They trot ahead of hunters with noses low. One stops. Its body tightens. Its head lifts. Fresh trail. The humans know prey is near before they see it. That is why domestication made people more frightening. It turned hunting into a partnership. Dogs did not just add teeth, they added another sensory system. They could smell hidden animals, follow tracks, flush prey from cover, keep pressure on a runner, guard camp, and warn early. For wildlife, the risk changed. A lone human might be watched from a safe distance. But a human voice mixed with dog scent, paw prints, or barking can mean something larger. An organized hunt with more than one body and more than one set of senses. That is the twist. The wolf became a camp follower. The camp follower became a hunting partner. Humans became a two-species predator. This helps explain why off-leash dogs and dog-scented trails can make animals avoid places, even when the owner means no harm. The effect varies by species, rules, distance, and past experience. So why can a human voice alone still push animals away from food, water, and shelter? Boot prints sink into wet soil beside a narrow trail. A human smell drifts on the wind. Far away, an engine rumbles, then fades. No animal is chased, no animal is killed. But the place has changed. Animals don't just fear a predator. They fear places. So how can fear of humans last when people are not hunting? Many wild animals build a risk map from cues. A voice near a waterhole, footsteps on a path, fresh tire tracks by a road, a headlamp in the dark. One cue may not matter, but when the cues return, the map updates. This is the landscape of fear. Safe ground and dangerous ground shift with time, scent, sound, light, and memory. Here is the key twist. Fear does not need a direct attack to cost an animal something. If a herd avoids the best grass because people pass nearby, it may walk farther for worse food. If deer delay a trip to water, they lose feeding time. If monkeys watch a trail instead of eating, they spend energy staying alert. These are non-consumptive effects. Humans can change wildlife behavior without killing any animals. Presence alone can alter movement, feeding, stress, and access to water. The map also spreads through learning. Young animals follow adults away from roads. Groups react when one member gives an alarm. Animals remember bad encounters. In places with long hunting pressure, evidence suggests bold individuals may be removed more often, so cautious behavior can become more common over generations. But this varies. Some animals learn that predictable hikers, quiet vehicles, or protected trails are lower risk. That means tourism, road planning, and recreation rules matter. So if human signals can create fear, why do some animals still move toward people and even use us as cover? Sometimes we are the threat. Sometimes we are the cover. A human voice rolls down a slope. An elk snaps its head up, then slips into the trees before it sees a person. In a busy park, people pass all day. Some animals barely look up. They keep eating. The pattern feels predictable. Near a road, a small animal feeds close to traffic. It is not trusting cars. It may be using us as a shield, because predators often avoid people. So, if humans can be a strong warning, why do animals not always run? Because human is not one signal. Wildlife reads place, history, and pattern. In hunted areas, a voice can mean danger. In tourism areas, where people stay on paths and do not chase, animals may learn to tolerate us. In some places, our presence may lower risk from wolves, cougars, or lions. That is the twist. We are not only predators in an old story, we are mapmakers of risk. So use that power carefully. Keep distance, stay quiet, leash dogs, stay on trails, do not crowd water or food. If we change the pattern, we change the rules they live by. If you like this video, don't forget to like, share, and subscribe to stay tuned for future videos.